Okay, so here we've got here this part that's made for an engine. It's made up of a cylinder and a hemisphere, okay, with the same sort of radius. And then there's like a rod here, it says, which is sort of trying holding it in place, yeah, so it doesn't topple. Okay, and we've got the angle here of the rod. Okay, the angle of elevation, yeah, of the rod to the top of the solid part. Now, you'll notice here, okay, we've got a triangle, yeah, right angle and an angle there, so that brings in the SOHCAHTOA again, yeah. But they also mentioned about volume here. So this is the total volume of the solid part is 8.6 centimeter cubed. We've got the radius as well. That's interesting. The radius, it says there, the hemisphere and the cylinder is 0.9, so I could even add that in there. Okay, so we know the radius there is 0.9. Now what else do we know? Well, we know that in terms of the height here, that's also going to be 0.9, isn't it? Yeah, because that's the way a hemisphere works. Okay, it's just the radius. What we don't know is the height of the. We don't know the height of the cylinder. Okay. And perhaps if we knew the height of the cylinder, we then know this height here. So I'm thinking if we know this height here, we could then maybe work out the length of the rod, okay, using SOHCAHTOA, right? If we can work out this height here, because that is one side of the triangle, isn't it? So, if we first of all think about the volumes here, well, the volume of the hemisphere is 2/3 pi r cubed, okay, which is 2/3 times 3.14 times the radius cubed, so 0.9 cubed. Okay, so if I work that out on my calculator, 2/3 times 3.14 times 0.9 cubed, that comes out to be 1.52604. So that's the volume, if you think about it, of the hemisphere, but we're told that the total volume of the solid part, okay, is 8.6. So the total volume, of course, would include the cylinder and the hemisphere. So we could literally say, couldn't we, the volume of the cylinder plus the volume of the hemisphere is equal to 8.6. Okay, the volume of both of them combined is 8.6. Now we know the hemisphere volume, so that's 1.52604. But we don't know the volume of the cylinder. Having said that, though, now that I've got this set up, because I know the hemisphere volume now, I can take it away from the total volume to get the volume of the cylinder. Okay, so that will be 8.6 minus 1.52604. Okay, so we get, that comes out to be 7.07396. Okay. Now remember, the cylinder has a formula, pi r squared h. Okay, so now I could maybe work backwards to work out what that h is here, what that height is of that cylinder. Okay, so 3.14 times 0.9 squared times h is that. Okay, so then you work out what you know, then you can work out the 3.14 times 0.9 squared, and we get 2.5434 times h is that. So then h would be, because I know that, take it over to the side and divide, okay, by 2.5434. So I get my height then to be 2.78. Okay, so it's not particularly, excuse me, it's not particularly nice number, but that's what it comes out as. Okay, so 2.78. Now what's good is, because I know h is 2.78, I can actually get then the I can get the whole height here, yeah? So 2.78 plus 0.9 will be 3.68. So 3.68 would be the height of the whole object. And now if I focus on my triangle here, hypotenuse here, of course, opposite the right angle, and then opposite here, the angle, those are the two sides I'm going to use, okay, with SOHCAHTOA, because I want h and I want the length of the rod, and I know O. So of course with SOHCAHTOA, it'll be sine 68 equals the opposite, which is 3.68, over then the length of the rod, which we call h. And all you've got to do then is to get h, just swap them round, yeah? Take the h up, and then you end up taking the sine 68 down. Okay? So we get h to be 3.68 divided by sine 68, and that comes out to be 3.97 if I go for 2 decimal places. Okay? So that would be then in centimetres. Okay, so practically 4 centimetres, yeah?